Alright, welcome. I wanted to do this quick video here, quick tutorial on EKG recognition specific to 12 leads. I got asked recently if I could cover some of the basic information about the different waveforms and then specifically tying it into 12 lead EKG, MI location, and things like that. So I want to make a quick short video that kind of covers the very basics of it. This will be one video in a series of videos that are used to help identify EKG anomalies specific to myocardial infarction. All right, so the first part here, the first thing I want to cover is the basic EKG rhythm. So I have here on the screen this real generic QRS complex. And one thing that seems to confuse people right off the bat is what areas are, or what's occurring with each specific area of the EKG. So the P wave, located between my two red lines here, right? This represents atrial depolarization, and that's a pretty basic concept. Everybody seems to know that. There is some confusion sometimes about whether or not that is the A node, the SA node firing off, or some other thing. But what that represents is the atrial muscle contraction. And so that's pretty basic EKG 101. The area that I want to focus on right now is the QRS complex and what we call J point, because this is what's going to be important to us when we look at 12 lead EKGs and we're looking to figure out if the patient has ST elevation or ST depression or any type of changes that may indicate that there's something going on. So the first concept here is the concept of the QRS complex. So when we look at a QRS complex, these have many different forms and it can be a tad bit confusing. So the image that you see on the screen right now is a true QRS complex, but not every EKG looks like that, right? So at times we'll have a QRS complex that looks like this. And so the problem is we call everything a QRS complex, but by definition, this would be considered a QR complex, right? There technically isn't an S wave. And if we refer back to our complex on the side here, we can see that the S wave is the negative deflection that comes after R. So that's kind of step number one. To understand where you should be looking, you kind of have to recognize which type of complex you're looking at. So in addition to a QR, you could have an RS wave, right? In which this would be our R wave and this would be the S wave. And then there's a number of other variations. We call this complex a QS wave, right? And we call that a QS wave because without an R wave present, the positive deflection after P, without the R wave present, we don't know if this is a Q wave or an S wave. And that's going to become later important to us later on as we look at MIs in different areas. So initially, as we go back to our main complex here, this main image, we can see all the different intervals here listed in the different waveforms. Now, one other portion that seems to be a bit confusing is what specifically is each one of these waves. So in the first complex that I've drawn here, I want to show you guys here, this highlighted section here, this void, that technically would be our Q wave, right? So our Q wave extends from isoelectric down to the nadir and then back up to isoelectric. So it's not just one line of that waveform, it's actually that entire void or that entire space that's being outlined by the printer or the screen that's reflecting this EKG waveform. So in the same image, the R wave would be from isoelectric line here all the way up to the point and then back down again, right? And that would be considered our R wave. And as you can possibly imagine, same thing would be true for this S wave here in green. So from isoelectric down to the nadir of the S wave and back up, or the nadir, that would be considered our S wave. So not every QRS complex that we encounter is going to have a Q, an R, and an S. Sometimes, depending on which lead we're looking at, we may only have an R wave. We may only have a QR complex. So understanding that is really going to become important to us when we look at ST changes specific to MIs. So if we continue down our complex here, the next section that I really want to focus on is what we would call J point. So J point is this area right here that the arrow is pointing at. All right, so this little area right here is J point. And so J point is considered the point where the S wave turns and goes back towards isoelectric. Now again, we may not always have an S wave, so it can also be the area where the R wave turns back towards isoelectric. So the J point is that moment when the complex seems to terminate and the waveform begins to go back towards isoelectric. And so the area that we want to know about is J point, right, this red dot, plus 40 milliseconds, or one small box. So we would look in this section here, if this was on EKG paper, right, if this was a tracing on an EKG paper, we would look for J point and then one small box. So in our first example over here, in this case, J point would be somewhere in this area here, right? So it would be about there. And then same here. And then in the QS wave, it would be about there. So that's J point plus 40 milliseconds. Now, if that area is elevated, meaning it's higher than the isoelectric line, then that's our first cause for concern. If it's lower than isoelectric line, that can also be a concern, right? And so either one of these variables can be important to us, and so we want to be on the lookout for both. Now, when we say it's elevated in comparison to the isoelectric line, we need a good place that we can look at to see exactly what we're going to consider isoelectric. In this example, and in most EKGs, the best place to look would be the T to P section, right? And so from the end of the T wave to the beginning of the next P wave would be the best place to look. So if this J point plus 40 milliseconds is elevated in comparison to the TP section, then we would consider that to be ST elevation. Now, in and of itself, just having it elevated isn't enough criteria for us to call this an infarct. We still have to have other criteria also available to us. But this is a very basic generic starting point. When we look at the elevation of J point, in most leads, we want to see at least 1 millimeter of elevation. If we have at least 1 millimeter of elevation, then it's enough to consider it significant or potentially a sign of an MI. Now again, there's other criteria that we're going to need, multiple leads, depending on the leads, which leads, if they're looking at the same area. But the rule of thumb is 1 millimeter of elevation is enough to consider that elevation significant. And again, that's 1 millimeter in comparison to the TP section here. So when we're initially looking at an EKG and we're wondering if there's the potential for an infarct, if patient's having chest pain and we want to look at it as a pre-hospital professional, we're paramedics out in the field, we take our 12-lead EKG, we're going to look for ST elevation. The way we do that, we're going to find J point, the area where the S wave turns back towards isoelectric, plus 40 milliseconds, one box, and then compare that section to our TP section. If it's elevated 1 millimeter or greater to that, we're going to consider it significant, and we're going to keep looking for the other indicators. Thank you for watching that video. This is the beginning of hopefully a series of videos that'll help better explain 12-lead EKGs for pre-hospital professionals. A little bit of background, I'm a paramedic working in the field. I teach a paramedic program, and I wanted to offer some videos that kind of help clarify some of this stuff that hopefully make it less challenging and less of such a complex issue or complex concept. So this is the first of a few. Again, if you like the video, please like it, subscribe. If you have any questions about any of the content, leave comments down and below. And hopefully I'll see you back for the next one. Thank you.